students. In this video, I am going to discuss solution chapter Vanthoff factor numericals. Okay, why Vanthoff introduced factor? What is the reason? So first I'll give you explanation. Afterwards we move on to the numericals. We have shortcuts also, so we can move on to the questions afterwards. First, Vanthoff factor. Vanthoff factor we are represented by the letter I. See here. Colligative properties first. We'll discuss just 1 minute about colligative properties. Colligative properties are properties. These are the properties. These are the properties which are depends on only number of moles of non-volatile solute. Okay, if you add more number of particles depends on number of particles. Previous video also we have discussed some questions. More number of particles, more elevation in boiling point, more depression in freezing point, more osmotic pressure, like that. Okay, here only depends on number of moles of solute particles, non-volatile solute. Only that point colligative properties prime we have learned. But Vanthoff introduced one factor. Vanthoff factor, what he is telling? Vanthoff factor represented by the letter I. What Vanthoff is explaining? This non-volatile solute, we have two types. The one we call it as dissociation type, or ionization. Sometimes in numerical part they are giving ionization also, both are same. Dissociation or ionization. Another one is association. Okay, so let me discuss first when it dissociate particle, when associate particles. Suppose, look into this, salt you can take it, sugar you can take it. Okay, salt I am taking. First, before that, I am giving some important points to you students. First, write down dissociation type. Dissociation, or also call it as ionization. Okay. Now here, all ionic compounds, strong electrolytes, and weak electrolytes undergo ionization in polar solvents. Polar solvents is nothing but like we are taking water. Okay, if you take NaCl, that too I am going to discuss another point. If you take strong electrolytes, complete ionization. If you put in water. So examples, all strong acids, HCl, H2SO4, HNO3, all strong acids. And next, all strong bases like NaOH and calcium hydroxide, all KOH, first A group hydroxide, second A group hydroxides, all hydroxides, strong bases, complete ionization. Next, all salts. Next one, all salts. Okay, so like NaCl, next to MgCl2, all salts also complete ionization, AlCl3, like this. Okay, students, look into this. Suppose NaCl, put in water, polar solvent. Then what happened? Dissociated Na plus Cl minus. Right. So complete dissociation, complete ionization takes place. Even HCl also, HCl in water. What happened? Complete ionization, H plus Cl minus like this. Suppose if you take weak electrolyte, what happened here? Partial ionization or else less ionization takes place. So what is this? If the best example which we are using frequently, yes, acetic acid and acids and hydroxide, ammonium hydroxide. These are weak electrolytes. Now look into this. CH3COOH, if you put in water, polar solvents, then what happens? It dissociates CH3COO minus plus H plus. It is partial dissociation only, partial ionization only, but it became to two particles. The same compound, if you put in organic compounds like benzene or CCl4 or else CS2, then what happened? What happened here? Dimerization, important point. Dimerization. See here, this CH3COOH, CH3CO, yes, CH3, C double bond OH. This one bond with like this. This is plus, this is minus. This is minus. Okay, this is plus. So intermolecular hydrogen bonding. Finally, one particle, two particles. If you add two particles finally became one particle. That we call it as dimerization. Dimer. That is, we call it as association type. This is what we call it as association type. Did you understand? When your solute particles associating, when it is dissociating? Once again, I can show the points here. Look into this. Dissociation or ionization. All ionic compounds, strong electrolytes, weak electrolytes undergo ionization in polar solvents like water. Strong electrolytes, again, complete ionization. What are strong electrolytes? All strong acids, strong bases, all salts. So that's why to understand here, I gave some examples. NaCl, if you put in water, ionization. HCl, ionization. CH3COH, partial ionization. This is weak electrolyte, so partial ionization if you put in water. That is, this is dissociation, or else what we call it as ionization, right? Okay. Now the same particle, the same solute particle, I am taking in different solvent. Then what happened here? Dimerization due to hydrogen bonding. So it can show what is this? Hydrogen bonding due to intermolecular hydrogen bonding. So two particles became to one particle. That we call it as dimerization. Not only acetic acid, students, even benzoic acid. Depends on solvent. If you take it in water, what happened here? Dissociation. Right. If you take it in what is this another one like benzene, another solvents, non-polar solvents, what happened here? Association type. So this one Vanthoff given information. Colligative properties are depends on number of moles of solute particles only, there is no doubt. But the solute is different types. Association type we have, dissociation type we have. Suppose dissociation type, what happens, students? Look into this, you can understand easily here. If you put in water acetic acid, what happened? One particle became. Here, how many particles? Two particles. N equal to 1 here, N equal to 2. Number of particles increases. What happened? Colligative properties increases, right? So this depends on solute only. It became 2, definitely colligative properties effect is more. Suppose if you take in dimerization, 2 became 1, then what happened? So here actually starting N equal to 2, end is N equal to 1. So it decreases. Decreases means what happened? Colligative properties decreases. Right. So that he had given information to us. Clear point, students? Okay. So write down now points, final conclusion points I am giving. Yes. Dissociation type, final conclusions I am giving. Dissociation type, higher the number of particles, higher the number of particles will lead to higher value of colligative property. Higher value of colligative property. That's it. Okay. See, I am giving one example. NaCl dissociated to Na plus Cl minus, right? So this is suppose if they had given KCl, KCl also you can write K plus Cl minus. Suppose they had given AlCl3, yes, it is also salt. How it is dissociated? Al plus 3 plus 3Cl minus. Here particles n equal to 2, here n equal to 2, n equal to 4. Like that we are going to calculate. Clear? But each and every question you can calculate like this, each and every example, or else we will go for general calculation also. What is the general calculation? Suppose if you have taken AN type, AN number, many N moles you have taken, then it dissociated to, what is this? Na moles. Na moles, that's it. Starting it is 1, it is 0, product 0. After certain time, how much it is dissociated? Alpha times it is dissociated. Alpha is nothing but degree of dissociation. Alpha is nothing but degree of dissociation. How much dissociated? Exact value we don't know. That's why we are representing alpha. Sometimes in numericals they can mention 30% ionized or else 20% ionized. That means 30% means 30 by 100. That means 0.3. Here 20% is nothing but 20% is nothing but 0.2. Like that we are calculating. But here number we don't know. Generally we are taking 1 minus alpha. This is n alpha, right? So I equal to Vanthoff factor. In terms of number of particles, how we are expressing? Total number of particles after dissociation, or association. Sometimes associated particles we are taking, sometimes dissociation, but here it is dissociation by before dissociation, before dissociation or association. That's it. This value always you will get 1 only, students, because starting always 1, no? That's why finally above numerator only we can take it. Okay. We will simplify this one. Yes. Write down. I equal to 1 minus alpha plus n alpha by 1. So I equal to finally what you will get? 1 minus alpha plus n alpha. Here you can take it as alpha common, alpha into n minus 1. Here n equal to number of particles. That's it, students. Alpha already have written degree of dissociation. Alpha they will mention number of particles. If you know, I easily you can calculate. Okay. Now clear. Now after that sometimes they will ask alpha also. Alpha from here how to write? I minus 1 by n minus 1. This one also you can take it. Clear, students? That's all. Associated type, dissociated type. Okay. Now I am giving one question. Here I am giving one question. Calculate Vanthoff factor. Calculate Vanthoff factor for potassium ferrocyanide. Potassium ferrocyanide when alpha 100% dissociated. Alpha 100% dissociated. See, they mentioned here dissociation. Then what is the formula? This is the formula, right? So here two different ways you can do this question, students. First of all, what is potassium ferrocyanide? You can note down K4FeCN6. It can dissociate it too. This is outside the complex only, free ion. Complex never dissociate. The complex always one only, never dissociated. How it can dissociate? 4K plus, next one, this is FeCN6. How many plus charges here? 4 plus. Definitely this is 4 minus. Overall compound value must be 0, right? That's all. This is the way you can do. So finally, how many particles, students? Here 4, here 1. 4 plus 1 equal to 5. 4 plus 1 equal to 5 particles. That is nothing but n equal to 5, number of particles. Use this formula. Vanthoff factor, they are asking you dissociation type 1 plus alpha into n minus 1. 1 plus alpha, how much they will give? Alpha 100% dissociated. 100% dissociated is nothing but simple your numerical, students. 100% alpha 100% dissociated means you can take it as alpha equal to 1. Simple. 1 into 5 minus 1. Then what you will get? 1 plus 4. Then you will get what? 5. Clear, students? See, if you calculate this method, you are getting answer is 5. This method also answer is 5. So I am trying to say one more point. Listen. Note point. What is the note point? If alpha 100% dissociated, if alpha 100% dissociated, then what happened? I equal to n. I equal to n. Clear point? That's it. Easily you can work out the questions. Clear? Now, next, another example I am taking. Suppose association type is there. Association type is there. How to do this one? General method. Association type means 2 became 1. Association type. Joining. Association is nothing but joining. 2 became 1. Then what we call it as dimer. 3 became like 1. Trimer. Trimer. Like that. So like we are mentioning, dimerization means 2 particles became to 1 particle. Trimerization means 3 particles became to one particle, right? So now I am going to do here one point. If solute associated type, the number of particles less than expected. If solute particles associated type, the number of particles less than expected, and hence it leads to lower value of colligative property. Lower value of colligative property. We expected some value, but less than that we are getting. Why? Because the type of solute particle is association type. Suppose you will take like this. Na particles I have taken. Finally became An type. Ulta of above case. Right? So then you can calculate what is this. Starting you can take it as 1. This is 0. And this is what, students? 1 minus alpha. This is alpha by n. Previous case I showed, no, 2 particles I have taken. It became 1. If you take 1, 1 by 2. That's it. So now calculate I. What is I, students? How to calculate? So how to calculate? After dissociation by, before dissociation, 1 minus alpha plus alpha by n. So then by 1. Before dissociation always 1 only, no? 1 minus alpha plus alpha by n. So here how to write, students? Finally you can write I equal to I minus alpha plus alpha by n. You can take this one. Or else you can write here alpha equal to I minus 1 by, you can take it as common, this one. So how to take common? I equal to 1 plus alpha, then write 1 by n minus 1. Can you write like this? Yes, you can substitute alpha equal to I minus 1 by 1 by n minus 1. That's it. This is your final expression. Depends on numericals we can do. Okay. Is it clear, students? That's all. Now another point. Last one is non-electrolyte. Non-electrolyte. With theory, many questions we can cover. Non-electrolyte. Non-electrolyte is nothing but neither association nor dissociation. Neither association nor dissociation. Example, simple way you can remember. Urea. What is urea? This is first synthesized organic compound NH2C double bond O, NH2 is molecular weight equal to 60. Okay, and the next afterwards easily you can remember all carbohydrates. All carbohydrates means gender frequently asking examples I am writing here. All carbohydrates, students. Glucose, monosaccharides, fructose. Next, like disaccharides, sucrose, maltose, and lactose. That's it. Glucose, fructose, same molecular formula, C6H12O6. Its molecular weight is 180. Sucrose, maltose, lactose, same molecular formula, C12H22O11. Only functional group changes. Molecular weight 342. Okay, that's all. These are commonly asking questions. Here I am telling one point. Here I equal to 1 always. Why? Because neither association nor dissociation. Always urea if you take, no doubt I equal to 1. So urea, glucose, fructose, anything it is there, I equal to 1. Okay. Now next one. Another important point I am writing. For dissociation type particles are there, then what happens? I greater than 1. For association particles are there, association type, then what happened? It is I less than 1. Okay. Next one. For non-electrolytes, I equal to 1. So important data. Okay. So now next one. We'll go for some numericals. Seems to be biggest numerical, students, but it's very easy. So based on that, finally Vanthoff given modified colligative properties formulae. So write down modified colligative properties. Actually, colligative properties related to lowering of vapor pressure. How much value have written, students? P10 minus P1 by P10 equal to W2 by M2 into M1 by W1. Here also same thing. But here what is the modified one? Modified one he had given. What is this? Check it. As it is he has written. But here into I into. So I is nothing but association, dissociation type. If you add I, then only your answer is correct, he was telling. Yes, it's true, proven. Association type is there, I different value we are getting. Dissociation type is there, I different value. That's why all modified forms we can take it. Suppose elevation in boiling point. Elevation in boiling point. What is the formula? Delta T equal to E into G into M. So before I is not there, now I add it. Next, depression in freezing point. This is all I can write. Elevation. What is the, students? Better to write full form. Elevation in boiling point. Depression in freezing point. Delta TF equal to into KF. Then last one, what is the osmotic? So pi equal to I in C to R T. That's it. I we added. Clear, students? Now based on this we can work out some numericals. Question number 2. 2 grams of benzoic acid. One question already discussed. 2 grams of benzoic acid dissolved in 25 grams of benzene. 25 grams of benzene shows a depression in freezing point. Shows a depression in freezing point equal to 1.62 Kelvin. Molar depression constant, molar depression constant for benzene, depression constant for benzene is 4.9 Kelvin gram per mole. Okay. Now, what is the percentage of association? Is the percentage of association acid benzoic acid if it forms dimer in solution. If it forms dimer in solution. That's all, students. That's all. Now, can you do this question? Can you try this question? How to calculate first one? What they're asking, percentage of association of acetic acid, it forms dimer in solution. Percentage of association. That means I they're asking. I they're asking. So what is this? 2 grams of benzoic acid dissolved in 25 grams of benzene shows a depression freezing point, molar depression constant, everything they had given. How to solve this question? See, students, what they're asking? They're asking. In terms of molecular masses, we have to calculate. In terms of molecular masses means what is the formula, students? Normal molar mass by normal molar mass by abnormal molar mass. Abnormal molar mass. Understood? Normal molar mass by abnormal molar mass. Normal means benzoic acid normal mass. Abnormal mass, how to calculate based on the given data. So note down what is the formula. Delta point they're asking, no, I into K into M. That's it. So now calculate, students. Calculate. Kf into M. Here first you can calculate, then M2. Kf into W2 into 1000 by M2 into W1. Calculate M2. How to calculate M2? W2 into 1000 by, tell me students, what is this? Delta T into W1. So what is the given information? Please note down. Please note down information. Please note down. What is this? 2 grams of benzoic acid. That is nothing but W2 equal to 2 grams. Okay. Next one, 25 grams of benzene. W1 equal to 25 grams. Next one, delta TF. Delta TF, how much they had given? Yes, 1.62 Kelvin. Go through the question and go back to the question. Note down all the information and try to do this question, students. That's it. KB, how much they gave? Yes, 4.9 K. That's all, students. If you substitute all the values, you will get M2. Can you calculate this one? Yes, try to do this one. M2 equal to Kf 4.9 into 2 into 1000 by next to delta Tf how much? 1.2 into 25. After simplification, here you will get answer 241.98 gram per mole. So now I you can calculate. I how to calculate, students? Normal molar mass by next. What is this? Abnormal molar mass. Abnormal molar mass. Abnormal means just know what you have calculated. So that is 241.98. What is normal? Normal benzoic acid formula. C6H5COOH. What is this benzoic acid molecular weight, students? What is the molecular weight? If you calculate 7 12s are 84. 84 oxygen 32 6. Then finally you will get 112. So substitute 112 by this value. Yes, that's all. You'll get answer. Finally, how much answer you will get here? Yes. What is this? 112 by 241.98. That's it. You will get answer here. What is this answer? 0.46. Anyone calculated 122? This is 112 or 122? 8 plus 3. 4 plus 6. 6 plus 6, 12. 8 plus 3, 11. 122. 122 by, how much, students? 241.98. How much? Anyone got it? Yes, 0.50. This is I. Degree of dissociation of benzoic acid. Degree of dissociation of benzoic acid. Degree of dissociation. Dissociation of benzoic acid. How to calculate degree of dissociation of benzoic acid? Alpha value, no? So alpha. I equal to, what is this formula? Alpha by N. Alpha by N. Alpha equal to 1 into N. Right. Alpha equal to, what is this I value? How much? 0.50. Okay. Into, how much, students? How much? Normal calculation you have taken, no? Better to go for this. What is this? I equal to 1 plus, what we have taken? alpha into 1 by n minus 1. Now you can substitute. Here I equal to how much we have calculated? 0.50. This is 1 plus alpha 1 by n, 1 by 2 minus 1. 1 by 2 minus 1. 0.50 equal to 1 plus, what is this? Alpha into minus 1 by 2. Right? So now you can calculate. Now you can calculate 0.50 equal to 1 plus 1 minus alpha by 2. 1 minus alpha by 2. Okay. From this you can calculate alpha. If you calculate alpha, how much you will get answer finally here? 99.2% you will get. This is your answer. Alpha by 2 equal to 1 minus 0.504. Can you simplify this one, students? Alpha by 2 equal to 1 minus 0.50. Alpha by 2 equal to, what is this? 0.496. Then alpha equal to 0.496 into 2. That's it. This is your answer, 99.2. Like this we can calculate. We are going by two different methods. Starting here I had given another way. That is little confusing, better avoid. Starting I had given simple shortcut, that you can use, and finally you can calculate. Okay, these numericals, it takes time to understand, but once you understood, definitely it is easy. Next, previous year questions we can see. Previous year questions. Sometimes only I calculations they will ask. Like first question what I had given like that. If they had given like that, your work is very easy. But sometimes little tricky questions they will ask. Alpha value they will give. Afterwards calculation of I. It takes little time. But if you go through the association type and dissociation type, what I gave method, short method, definitely easily you can work out the questions. Okay. Now we can take another numerical. 2011 competitive examination. They asked one question. I am giving here how many students will try. Check. Let me check. Yes. 2011 main question. 2011 main question. See. A 0.1 molal, a 0.1 molal aqueous solution of a weak acid, aqueous solution of weak acid is 30% ionized. That is dissociated type, ionized. Okay. If K for water is 1.86. Sometimes they won't give Kf value of water. This fixed 1.86 degrees centigrade. Okay. The freezing point of the solution. The freezing point of the solution. Today, freezing point of the solution means what is the formula? Delta Tf equal to Kf into M. But they have given alpha information, that is nothing but including Vanthoff factor, I into Kf into M. We can take. So what is the given information? M equal to 1. Kf equal to 1.86. What about I value, students? I how to calculate? So above formula, ionization is nothing but 1 minus alpha. What is the formula? 1 plus alpha n 1 plus alpha into n minus 1. Clear? So from this you can calculate what is this I value. Alpha they give. Alpha how much they give? Alpha equal to 30 by 100. 30% ionized. Okay. So 3 by 10 means 0.3. Alpha you know. What about M? N. What about N? Weak acid. Any weak acid like acetic acid you can take enough. What is this? CH3, COO minus plus particles here, N equal to 2. Okay, I equal to 1 plus, okay, 1 plus alpha, that is 2 minus 1. Or some textbooks they had given, okay, 1 plus alpha. 2 minus 1, 1 only. So some textbooks directly they had given. For weak electrolytes, no. For weak electrolytes, I value directly you can take it as 1 plus alpha. Anyway, so why we have got 1 plus alpha, did you understand? That's all. Now I equal to 1 plus 0.3 alpha. They given, no? So finally 1.3. Now you know I, K, F, M substitute. Delta T to 1.3 into Kf 1.86 into molal. How much? 0.1 molar. That's all, students. You will get answer. Can you do the calculation? Yes. Anyone got answer? 0.24 degrees centigrade. That to freezing means they will give options minus values. Freezes. Minus degree centigrade. Okay, minus 0.24 degrees centigrade. That's your answer. Okay, can you do one more question? Question number 3. Question number 3. 0.5 molal, 0.5 molal aqueous solution of weak acid. Again, they mentioned here weak acid. Weak acid, they mentioned in bracket also. HX is 20% ionized. Here also ionization. If Kf of water, is 1.86. This is 2007 question. Kf 1.86. Afterwards, Kelvin. Yes. What is this? Kelvin, kilogram per mole. Units also important. Okay. Next, the lowering freezing point of the solution. The lowering freezing point of the solution. Did you understand Vanthoff freezing points or normal freezing points? Okay. Delta TF equal. Again, alpha ionization they had given means I into Kf into M. Again, same story. M equal to 0.2, K equal to 1.86. Yeah, HX, weak acid, no? Directly you can take it as I equal to plus alpha, right? So what is this alpha value, students? Alpha value how much? Alpha value 20% ionized means 0.2, right? That's it. You can substitute alpha equal to 20 by 100, 2 by 10, 0.2. I equal to 1 plus 0.2, that is nothing but 1.2. Delta TF I into I how much? 1.2 into Kf 1.0. So finally your answer is this one. What is the answer? Anyone calculated? Can you calculate what is the answer? Anyone got it? Yes. Your answer is 1.12. 12 Kelvin. See? Very easily we can work out Vanthoff factor numericals. Vanthoff factor numericals, starting it may take time to understand, but once you understood, definitely you can enjoy. So please, everyone, watch it and try to do all the questions which is related to Vanthoff factor questions. Definitely you can enjoy. 1.168 something you will get, nearly 1.12 Kelvin I have written answer. Okay. So Vanthoff factor, all the numericals I have covered, and the colligative properties also, what generally numericals they are asking, ideal solutions, non-ideal solutions also I have covered. Remaining, if you have any queries also, comment me. We will do coming days this video, students. Thank you. Thanks for watching.